So if you microwave it, increases the temperature, and those sugar molecules redissolve. Oops. Sorry, that should say sugar there. All right, let's go on to the next slide though. The trend we said for a gas dissolved in water is opposite. So again, on the x-axis, we have temperature in degrees Celsius, and on the y-axis, we have solubility. And notice that as you increase in temperature, the solubility of all these gases is decreasing. Okay, the solubility of CO2 in water, which is a liquid, is going down, and for oxygen and these other gases as well. A good example here is when you think about a carbonated drink. So any carbonated drink, but if we're just thinking about carbonated water, like sparkling water, if we had sparkling water at room temperature, a can that we opened and took a drink of, and then we had a can of sparkling water in the refrigerator. Okay, so we have room temperature carbonated water versus refrigerated carbonated water. Which one is going to have more fizz when you take a drink? Okay, obviously the cold one will. And the room temperature will have less fizz if we've opened those containers. And that's because the more you lower temperature, okay, so the lower the temperature, equals more gas dissolved in the liquid. But as we see on the figure, the higher the temperature, the less gas that's dissolved. So these two trends can get confusing. People can get tripped up here remembering, oh, which one was it? Was it for solids if you increase temp, solubility increases, or was that for gases? So make sure you study these things. Make sure you even really go over these two phrases up here and look at these charts, and remember, as you increase temperature, solids dissolve more into their liquids, but as you increase temperature, gases become less dissolved in liquids. Okay. All right. Now we are at we're going to think about solutions with regards to pressure as well, and that's where Henry's law comes in. So kind of take a pause, new direction here. Henry's law, we'll just read it. Henry's law says that the concentration or solubility of a gas is directly proportional to the partial pressure of the gas when the temperature is constant. So you should actually be familiar with that term, partial pressure. We had a whole law on partial pressures, Dalton's law of partial pressures from chapter 8. So ultimately, to summarize, what we're saying is that pressure changes. It can affect the solubility of a gas in a liquid. And really the key understanding here is that as you increase pressure, you're going to increase gas solubility. Henry's law looks a whole lot like Boyle's law or Charles' law or Avogadro's law. It just has its own units. So Henry's law says C1 over P1 equals C2 over P2. And C here stands for the concentration of the gas in the liquid. So to explain Henry's law, if you look at this figure, if we have a liquid with a dissolved gas in it, okay, and then above the liquid, and this is a closed container because we have this lid here, Above the container, we have some gas molecules. So here we have gas dissolved in the liquid. And up here we have just gas particles. Okay. If we were to push down, see this arrow, push down on this lid, you should see 1, 2, 3, 4 downward arrows indicating that we're going to force more of these gas particles, okay, down into the liquid. All right, we're going to increase the solubility of the gas in the liquid. And then eventually equilibrium will be restored, is what this last figure is showing you. But when equilibrium is restored, you have more gas particles in the liquid. So Henry's law, again, if you go back up here, increased pressure means you're increasing the solubility of the gas in the liquid. So let's look at a little example problem to make sure we understand what this is saying. So I'm just going to write the law over here. C1 over P1 equals C2 over P2. So let's read this practice problem. It says when the pressure of oxygen is 159 millimeters of mercury, this is units of pressure, so this is P1. At this pressure, it says the solubility of oxygen in blood is 0.44 grams per 100 ml. So this is a units of concentration, so this is C1. Then it says what is blood solubility at 11,000 feet elevation where the partial pressure of oxygen is 56 millimeters of mercury. So this is another unit of pressure, so this is P2. So what we're looking for is C2. So we have 3 of the 4 pieces. We're going to solve for C2. And if we're going to solve for C2, we need to rearrange this equation. So let's draw a rearranged equation where C2 is by itself. So to rearrange this, I'm going to cross multiply both sides of the equation by P2. I don't really have space up here, but we're going to times by P2. And it cancels out on this side. What we're left with then is C2 equals C1 times P2 over P1. So again, with these kinds of laws, Boyle's law, Charles' law, Henry's law now in chapter 9, I encourage you to rearrange your equation first before you go plugging in all the numbers and units. The other thing I'm going to mention before we solve this is you need to know that units of concentration are going to stay gram per 100 ml. This 100 ml up here, where I've labeled C1, you're going to treat it like it's a unit. You're not actually going to divide this 0.44 by 100. It's part of the units, okay? Do not divide 0.44 grams by 100. Leave it as 0.44 per 100, okay? So hopefully you'll understand what I mean when you see me work this out if that was confusing. But let's just plug everything in. C2 equals 0.44 grams per 100 ml. Normally I don't encourage writing your units like this, but because we're leaving this all as units, even the number, I'll write it like this. So that's C1 times P2, which is 56 millimeters mercury. And then we're going to divide by P1, which was 159 millimeters mercury. Okay, I actually don't have this calculated out, so give me a second. So we'll do 0.44 times 56 divided by 159, and you should get that the concentration of oxygen at a higher elevation where pressure is lower, concentration should therefore be lower according to Henry's law, is 0.15, we'll just say 155 grams per 100 ml. Okay, so if you notice, as you go from P1 to P2, pressure is decreasing. And according to Henry's law, if we increase pressure, we increase gas solubility, okay? But if we decrease pressure, the opposite is true. We decrease gas solubility. So here, as we decrease pressure, you find that your final concentration is lower. It went from 0.44 grams per 100 ml to 0.155 grams. And you're going to report these units as gram, again, per 100 ml. Do not divide by this 100. You just leave it as part of the units. Okay? So there is our answer.